Hello everyone, in this video we are going to create algorithm which identify the face in the image and blur it. It started and let's take our file. So this is the our image which we will try to blur it and create algorithm on it. For that we have to first of all install the library, that is pip install, and which library is it is OpenCV, and second library will be our Matplotlib. So I have already both the libraries, so I will not install, but you have to install if you don't have the. And next we will import these libraries, so cv2, and next one will import matplotlib .pyplot as you can say as plt. Why this is because it is used for the plotting the image. Main purpose is this. And second one, what it will do, it will identify the image, identify the image and load it, and other works will be done by cv2 library. So import that image into the our Jupyter notebook. So for that, image equals to the cv2.imread. imread is reading the file, and which file is, so we need the name of the file, which is our location. Copy relative path, I've copied that, and we have to paste it here. Now we get our image, and next is we have to convert its image to the RGB. Why? Because when we read the file from the cv2, what it gives us EGR form of data of the image. So we have to convert it to RGB image. So for that we have image equals to the cv2.cvt convert color, and in that we are going to pass image comma our cv2 dot color or in which we are to change, so bgr to rgb. This is the our main line. Now we are going to plot it plt dot show image, and let's run it. And now we are running it, and it will plot this. Now it given the images, so this is our image we have successfully loaded to the Jupyter notebook. Now next what we are going to do is we are going to write the command. Our next goal will be to identify the face around it and to blur it. So the two steps will be there. First of all, identify the image. For that we are going to download a XML file, that is from the GitHub. This is GitHub from the OpenCV library. This is the OpenCV library, and in that there is file called Haar cascading. This is the link for that. I will put the link in the description also. And next we are going to download it. So there is an option called download, and we are going to download it. Now when you are downloaded, next we are going to put it to our VS Code directory. Now we got our image here, and first thing, if you download it and there is two, means sometimes what happens, we click 2 times on the download button, so our file XML file name should not be consist of any gaps. So let's delete it, and there should not be any gaps in the name of the XML file, and otherwise it will create a problem. Now we are going to copy the path, copy the relative path, which is file name. We have copied the file name, and next what we are going to do is our model, or you can say model, will be equals to the cv2 dot will be cascade classifier. Basically it is a cascade classifier. In that we are going to put the our cv2 dot data, and dot there will be called cascade, sorry, Haar cascade, cascades, sorry, cascades. Now plus, and there this will be our location. So I have pasted the path of the our XML file. Now next step we'll do, what we are going to do is we need a gray image. What happens when we plotted this image? This is the RGB image, but for identification of the face we need a gray image. So how we get? So gray image, and we have to convert this image into gray. How? cv2 dot, as we are already done RGB2. So for same thing, color, and in that we are going to pass image comma cv2 dot color, and from RGB to gray, gray image, and now we can pass it to the our model. So faces, it will detect our face. So this was a model loading. So model load, and this to convert CVT convert to gray, and this is the basically we are getting the our faces. So it will give us boxes for the faces. So faces, what our model dot detect multi-scale comma bracket, and in that we are going to pass our gray image comma, and two parameters. First of all 1.3, and next one will be 10. Why? Let's understand these things. Why? This is the our image, as we know image, and second parameter is reducer. Second one is our 10 value, which is the basically nothing but a minimum size of pixel for any face to called as a face. So this is a min pixel, you can say, pixel to call it fetch. Next we get our face. Let's for loop it, because what happens, it gives us several faces, not one faces, because a one image can be have a several faces. So for that we have to loop it, and in loop we get the values x, y, w, and h, which is x coordinate, y coordinate, and the width and the height of the boxes. And after that in faces, now we can print x value to see how it actually giving the value and what value it is actually giving. So let's run it, and it is giving us 648. So there can be a pixel which is 648. Let's see on the image also. This is the 600 now. So on the 648, around this size, so it has given a their value. So x value will be on this area. So and next it will give us y value, and then width and the height we can easily create a box. So it has been given us this. Now after that we have get our faces. After that we are going to, what we are going to do is we are going to blur this area. So we have got our area of the face. Now we are going to apply the blur. So for the blur functionality we are going to do is image, let's say new, what or you can say face area. This is our face area. Face area will be image. We are taking the image which is our RGB image. So remember this, not gray image, because it will return us gray image, but we need a RGB value, RGB image, because to show the only the face part is baki, otherwise other should be colored. So image, and take only those values which is x, y to the y plus h, and to the x plus x to the x plus w. only these pixels. And after this we are going to write our function to blur it. This is our area. Now we are going to blur this area. So for that, blurred face will be equals to the, we are going to use the CV2 Gaussian blur, Gaussian blur, and in that we are going to pass our face area. This is our face area, and the size of kernel, let's pass is to 15 by 15 kernel, and next will be our value 10, which is our sigma value. Okay, so this is our sigma value. We have passed it. If you if you need get greater understanding how actually Gaussian blur works, then I have already uploaded the image. So I have already uploaded the video, so you can watch from the I section also. Now next is we will get here a blurred face. Next we are going to add this blurred face to the location where the face is. So to the image, and here we are y to the YH, comma, and x to the x plus w, and in that we are going to pass our blurred face. And let's print, or you can say plot, the value I am show, and in that we are going to plot our image. And let's run this command. What we are going to get, let's see. CV2 has no attribute Gaussian blur, so it should be double S, Gaussian blur. And now we got our final image, and this face is blurred here. So if you have any doubt, you can ask in the comment section below.